Hello everyone, I am Erica Grace O. Cortez from BSc E2C Batch 2. This subject is Engineering Data Analysis for CE under Engineer April X Lumibao. So for today's video, we are going to answer different problems about permutations and combinations. So here's our first problem. In how many ways can 5 starting positions on a basketball team be filled with 8 men who can play any of the positions? So we need to obtain in how many ways can 5 starting positions on a basketball team be filled with 8 men who can play any of the positions. We have 5 different positions, so ordering the player is important. Because the order is important, we need to use permutations. According to Theorem 2.2, the number of permutations of R objects taken from the group of N objects is in our case, N is equal to 8, represents the group of basketball players from which we choose. R is equal to 5 players to fill starting positions. So the number of permutation is therefore 8P5 is equal to 6,720 ways. Therefore, there are 6,720 ways. So here's our second problem. Find the number of ways that 6 teachers can be assigned to 4 sections of an introductory psychology course if no teacher is assigned to more than 1 section. We will use the following theorem. The number of permutations of P distinct objects taken M at a time is. We need to find the number of arrangement of 4 teachers selected from a group of 6 teachers. Because the order is important, we will use permutations. The number of permutations of 6 distinct objects taken 4 at a time is 6. Therefore, there are 360 ways to assign 4 teachers to these sections. So here's the third problem. In how many ways can 4 boys and 5 girls sit in a row if the boys and girls must alternate? There are 5 girls and 4 boys. Because their arrangement must be alternate, the girls will be at the beginning and at the end of the row. So if the B is boy and G is a girl, the row will look at like this. So there are 5 girls and 4 boys. Let's first place the 5 girls on their places in a row so we get the following arrangement. Let's now place the 4 boys on the places between the girls so we get the following arrangement. The number of permutations of these 4 boys is 4 factorial is equal to 24. So these 4 boys can be arranged among themselves in 24 ways. If an operation can be performed in n1 ways and if for each of these a second operation can be performed in n2 ways, then these 2 operations can be performed together in n1 times n2 ways. In our case, first operation, the number of permutations of 5 girls can result in n1 is equal to 120 different ways. Then, for each of these ways, the second operation, the number of permutations of 4 boys can be performed in n2 is equal to 24 ways. So, these 2 operations can be performed together. So, n1, therefore, there are 2,880 ways. Therefore, 4 boys and 5 girls can sit in a row with condition that the boys and girls must alternate in 2,880 ways. So here's the last problem. If 3 books are picked at random from a shelf containing 5 novels, 3 books of poems, and a dictionary, what is the probability that A. The dictionary is selected, and B. 2 novels and 1 book of poems are selected? So first one, let's answer the letter A. If 3 books are picked at random from shelf containing 5 novels, 3 books of poems, and 1 dictionary, so there are 5 plus 3 plus 1 is equal to 9. There are 9 books on a shelf. 3 books are randomly chosen. In order to calculate the number of ways choosing 3 out of 9, we need to use combinations, since the order is not important. Hence, we can choose 3 out of 9 books. Therefore, there are 84 ways. We need to find the probability that the dictionary is selected. Among 9 books on the shelf, there is 1 dictionary. Because the order is not important, we need to use combinations. To calculate the number of ways that we can choose 1 dictionary, therefore the number of ways to choose 1 out of 1 dictionary is. So here's for the first question, that what is the probability that the dictionary is selected? Therefore, there is 1 way. Among the 9 books on the shelf, there is 1 dictionary. So, there are 8 non-dictionaries. The number of ways to choose 2 out of 8 non-dictionaries is. Therefore, there are 28. If the first operation can be performed in 1 way, the number of ways to choose 1 out of 1 dictionary, and for each these ways that second operation can be performed in 28, the number of ways to choose 2 out of 8 non-dictionaries, then these 2 operations can be performed together in 1 times 28 ways is equal to 28 ways. So 1 dictionary among 3 selected books is P is equal to the number of ways to choose 3 books among which there will be 1 dictionary and 2 non-dictionaries, which is 28 ways, over the number of ways to choose 3 out of 9 books, which is 84 ways. This one. Therefore, there are 0.333 probability to choose the dictionary. So, we go for a second question. 2 novels and 1 book of poem are selected. We need to find the probability that 2 novels and 1 book of poems are selected. There are 5 novels on the shelf. We need to use combinations to calculate the number of ways that we can choose 2 novels. Therefore, the number of ways to choose 2 out of 5 novels is. There are 10 ways. The number of ways to choose 1 out of 3 book poems is equal to 3 ways. If the first operation can be performed in 10 ways, the number of ways to choose 2 out of 5 novels, and for each of these ways, the second operation can be performed in 3 ways, the number of ways to choose 1 out of 3 book poems. Then these two operations can be performed together. There are 10 times 3 ways is equal to 30 ways. So 2 novels and 1 book of poem can be selected in 30 ways. Therefore, P is equal to the number of ways to choose 2 novels and 1 book of poems. So there are 30. And the number of ways to choose 3 out of 9 books, there are 84 ways. Therefore, we will have a 0.3571 probability of choosing the 2 novels and 1 book of poems. So that's all for today in this subject, Engineering Data Analysis for CE under Engineer April Lex Lumibao. Thank you and have a good day.